Hello there, and welcome to the seventh and final episode of Complex Conversations. I am your host, Isaac Bate, and today we are joined by Matilda Huggett and Matthew Hollis. We will be discussing the applications of the Mandelbrot sets, and to start off with, fractals in nature.
Fractals are quite abundant in nature, from clouds to ferns to trees to mountains to coastlines. They're everywhere. These different fundamental features of nature use they don't use traditional shapes when defining them and how they appear. They use fractals, which are rough and not smooth.
Mandelbrot very famously said that clouds aren't spheres, mountains aren't cones, and coastlines aren't lines. Can you explain that a little bit?
That is right. When you zoom in on these features, for instance, if you look at a coastline, as you zoom in, it doesn't smooth out at all. It just gets keeps being rough and jagged, and then you can go all the way down to a small stretch, and it still does it. Yeah. And that's the same for all those other features like mountains as well.
What are some more practical uses of these graphics?
So there are so many practical uses of Mandelbrot maths and so many different businesses and industries. So you take computer graphics, it's apparent in the logistics set, the financial and stock markets, and it's even visible in some genetics.
Let's start off with computer graphics. How are they used?
Well, just like in nature, they're used to render mountains and coastlines in video game maps because they realize that would doing it like that saves a lot of time compared to manually having to do it, and it gives you more realistic and better results.
If you're trying to emulate real life, you'll use real life maths. Okay, next up, we'll talk about the financial market side of this.
So in financial markets and many economic models, maths the events are represented with the bell curve distribution, and this shows a very oversimplified model, which doesn't react well to shocks and unexpected events. However, if you take Mandelbrot maths into stock markets and financial markets, it can much better predict the effects of shocks and, honestly, effects of real world consequences. Also, Mandelbrot maths laid the basis for modern chaos theory in financial markets.
Yeah, that's because a small change at the start has a giant change later on. Basis of chaos theory. Next up, what is linked to the logistics map, and also what is the logistics map?
So this here is the logistics map. It has the formula of xn plus 1 equals rxn times 1 minus xn, with xn being the percentage of the maximum population and r being some growth rate. And as you plot it along with r along the bottom, you get different the values of xn plus 1 start oscillating. And this so happens to correspond with the reverse. If you reverse the Mandelbrot set, the first part of the logistics set with one line matches up with the largest first bulb of the Mandelbrot set. And then with the second bulb of it, that's when there's 2. And then when you go to the smaller bulb, it's 4, and so on and so on. And then it just becomes chaos with one small island of stability which happens to be where the little Mandelbrot set in front of it happens to reside.
It's important to mention that those bulbs represent the number of oscillations in them. So if you're in the first bulb,
you have 1.
It will converge down to 1 point. In the second bulb, 2 points. Third, and then 4 points. Then fourth, 8, and on and on and on. And there's little island of stability, which is a bit like a few. Right. Finally, diseases. How can we use Mandelbrot maths to model populations? How about this?
So diseases. So in diseases, Mandelbrot maths is really good because it takes, for example, let's take COVID-19 and one small beginning point person. It's very difficult to explain how the disease will spread. But Mandelbrot maths, there was shown some connection between the way COVID-19 spread and some Mandelbrot maths. Also, on the topic of biology, there is some. Let's take genes and these minuscule biological things that you can't see. DNA, yes. So there's lots of shown examples of fractals in this, which is also really interesting. And The Mandelbrot maths has been shown to map really well to gene mutation, as the one small change has a large impact, which is exactly what Mandelbrot theorized.
Okay, a theory once again. All right, that's everything we have time for. Thank you, you two. And they're not here, but thank you, Luke and Louis, as well, and Jason for one episode. Thank you for listening to all of Complex Conversations. We're very grateful. Goodbye.